My name is Paul Stone. I'm a security consultant. I work for Context Information Security in the UK. And I'm going to be talking to you this afternoon about clickjacking. So this is a quick summary of what's coming up. First of all, I'm going to give a quick introduction to clickjacking as it stands today, just for people who maybe don't know that much about it. Then I'm going to show you 4 new cross-browser attack techniques that take clickjacking and build on it to do some exciting new things. Then I'm going to show you a tool that I've written that allows you to experiment with these techniques and try them out, see how they work. And at the end, if I have time, I'm going to show you some browser-specific exploits that I found during the course of this research. But before all that, I'm going to show you this. Okay, so this is a puzzle game. It doesn't look very good because I wrote it. It's basically a sliding block puzzle game. You drag the blocks around. The idea is to try and get the red square out of this and onto the grey square. I don't actually know how to complete this. Apparently, it takes a minimum of 81 moves to complete, and that's if you know how to do it. So I'm probably not going to finish that now. But anyway, so this is a web game. Perhaps you're just playing it online. Looks fairly innocent. But let's take a look at what's going on in the background. All this information has been sent from my web browser to a remote attacker. Each of these frames here has some fairly sensitive information in. This is a document from Google Documents. This is the page it's stolen from. This is a Gmail inbox. This is the main version of Gmail. This is the Google Gadget version of Gmail. As you can see, the pages don't have any styling on, but the information is there. So there's various other things there as well. So how did that happen? Let's go back to this, and let's go back to the beginning and talk about the basics of clickjacking. Now, clickjacking relies on iframes. Iframes allow you to take one site and frame it in another site, so they're on the same page. Now, there's a few misconceptions about how iframes work. So I'll just go over them now. First of all, any site can frame any other site, even if they're not on the same domain. Secondly, even if the site's being framed as HTTPS, that still works, even if the outer site isn't HTTPS. Thirdly, if you're logged into a site, then all your cookies will be sent along with the request in the iframe, so that you'll be logged into that site inside the iframe. So that's what clickjacking uses. You might think that because the 2 pages, 2 different sites are on the same page, that an attacker can just read what's in that frame. But that's not the case. This is what the outer page sees in reality. And the reason for that is because the browser's same origin policy prevents any JavaScript access inside the iframe because it's from a different domain. So these are some errors up here that would happen if you tried to access the JavaScript. So clickjacking is a way to get around this and still do some bad stuff with what's inside the frame. So I'm going to quickly run through how clickjacking tech is set up. First of all, we have a target site. Twitter obviously was already targeted in a clickjacking attack a while back. So this is how they did it. First of all, we take the site that we want to we want to get the user to do something bad on the site, basically. So in this case, we want to get the user to click the tweet button and send this message to all their friends on Twitter without realizing what's happening. So first of all, we frame the site, and this page is called inner.html. Then we decide what area of the page we want them to click. In this case, it's the tweet button. Secondly, the second step is to use CSS to move the iframe up and to the left so that the target we want to click is on the top left-hand side of the page. The last step is to take that page and include it in another iframe, and then lets us crop the page so that only the particular target that we want the user to click on is visible. So in this case, it's the tweet button, and there are 3 different ways this can be done. First is to show the target fully visible, and This is called UI redressing. The way this could be used is, for example, using that button in another context. So persuading the user to click on it. For example, if it was a submit button, they may think they were submitting another form rather than the site that's being attacked. The second thing we can do is we can actually make the iframe invisible, and we can layer it over other content on the page. So in this case, we have a button that says something else, and we can layer the button on top of that and get these to click that. What will actually happen is they'll click on the button in the framed page instead of what's underneath it. The third thing we can do is use JavaScript to make the iframe invisible and very small and make it follow the mouse cursor, so that wherever the user moves their mouse, when they click, they'll be clicking on the target no matter what happens. Okay, so to fully understand why clickjacking is important, we need to compare it to other browser attacks. So some other attacks that take place in the browser are cross-site scripting and cross-site request forgery. Just for fun, I decided to Google these and see how many results I got for each. As you can see, cross-site scripting is by far the most popular in terms of Google results, and the other two have fewer results, with clickjacking at the least. If we, however, look at how long these attacks have been around, these are rough estimates, we can see that cross-site scripting, cross-site request forgery are fairly old attacks. Clickjacking is fairly new. Now, what we can do is take the number of results, divide it by the number of years, and we end up with a completely meaningless number we can put on the graph. Pretty much the only thing this shows is that although clickjacking has only been around a couple of years, there's a lot of interest in it, a lot of buzz, possibly because it has a much scarier sounding name than the other two. So I'm just going to quickly recap the other two, these attacks. First of all, cross-site scripting lets you inject JavaScript into a web application. If we can do this, you can run any JavaScript code on the site. It's pretty powerful, even though it's a fairly common, well-known attack. With cross-site scripting, we can read the user data, we can execute commands on the website, we can inject data, and so on. It doesn't require much user interaction. Cross-site request forgery is less powerful than cross-site scripting. We can send requests into a web application, perhaps by following a link from a website, and we can trick the web application into honoring that request to do something bad. Now, cross-site request forgery, with this attack, we can only put information into an application. We can't read back any results. So in this case, this My Bank site, perhaps we could transfer some money from one account to another, but we couldn't read back the page to see if it worked or not, at least not directly. Cross-site request forgery can be beaten and stopped by having a random token with each request. So in this case, you can see at the bottom, we have a random token that the website knows, but a malicious attacker wouldn't know, and therefore each request can be checked to make sure that it originated from the site and not from somewhere else. Clickjacking. The basics of the attack is it's getting someone to click on a button or something inside an iframe to do bad stuff. The other thing, when clickjacking was first announced, was the Flash vulnerability that allowed you to access a user's webcam and microphone. That's been fixed now, but most sites are still vulnerable to clickjacking. So clickjacking lets you bypass cross-site request forgery protection. Because the attacker doesn't know the cross-site request forgery token, we say, well, we can get around that by just getting the user to interact directly with the form. The problem with clickjacking is that we can only input clicks into an application. Now, if you think about it, there's only so much you can do just by clicking on things on the website. Perhaps you could click on delete all or something like that, but with clicking alone, there's not all that much you can do. So to make clickjacking more powerful, current attacks that have happened use clickjacking with cross-site request forgery. So this request you see on the page is what happens when you when you update your status on Twitter. So in this line at the bottom here, we have the random token and we have the status. If that random token isn't there, then the update won't happen. So a clickjacking attack, to be successful, we need to get some data into a particular form. Now, Twitter makes that easy because we can have a link that includes the status. So in this example, it's hello. If we open up that link